next we will do is systematic sample in 2 dimensions. This is sometime needed because, for example, we have a map, and in this map we need to select random sample of locations, right? So there is a x-axis here and a y-axis here, and we need a systematic sample of locations. So this is two ways to do this. One is called a aligned systematic sample, and the another one is called unaligned. Unaligned is very complicated and we will not talk about it. We'll talk about the aligned systematic sample. So now this is our area map, and we need to take a sample of 9 locations in this. So how do we proceed? So one thing we do is we're going to divide with, so n is 9, right? So to get to 9 we need to create 9. So we do 3, we draw 3 rows and 3 columns. Okay, let's just say we have these as A represents the rows and B represents the columns. So there are 3 rows and 3 columns, so A times B is equal to N. Okay, now what the other thing we will do in addition to this is we will also divide one of this sub area or one of this area into another set of columns and rows. We're gonna say that it has this B has R columns and there is M rows within this area. In each of the small sample we again choose M and R, and they are all integers. So M times R would be the sub-region, M rows and R columns. So we basically end up being a AM times BR grid structure, and the total subregions in this is going to be MR. So how many sampling units are there now? The total sampling units is A times B times M times R sampling units, and this is just nothing but N, so the total sampling units is N M R. Now let's think of this as a so for X and Y system they will have a coordinate. For example, they have a I coordinate, and I coordinate will be 1 all the way to R, and then the second one is going to be R plus 1, because we are just adding so for I we are selecting first variable will be 1 to r, so we're going to select variable 1 all the way to variable r, which will be r would be here, and the very next one from that is just going to be r plus 1, and this is going to be all the way to this number, which is so r, and then r plus 1, which is just going to be this number, and then all the way up to here would be 2r, and this will keep going till you get to, because the second number is going to be 2r and the first is r, so the last one is going to be b minus 1 m plus 1, b minus 1 r plus 1 all the way to b r, because we're gonna start with b minus 1, which is the one less than the last big row, which is the b here, r plus 1 all the way to br, and the same is going to be with the j, which is in the y-axis, which will start with 1 up to m, then it next is going to be m plus 1, this will go up to 2m, then the last one is going to be a minus 1 m plus 1 up the way to am. Now what we do is we select a pair of integer, say any random integer u and v, such that u is more than 1 but it is less than r, and v is more than 1 but less than m, to fix the location. And after you fix the location of the first selected unit in the first subregion, then the other units are selected systematically with an interval of r on the x-axis and y and m on the y-axis, thus getting one unit from each of the, we are still going to get just 9 units, but we're gonna get it from each of the subregions. So how would that be? So x is going to be u, then u plus r, then u plus 2r, then u plus b minus 1r. Y is going to be v plus m, v plus 2m, and v plus a minus 1m. So this is the coordinates, but what actual locations you're going to be? So the first is going to be uv, the next is going to be u, v plus m. Look, imagine this is like this, right? So u, v is here, the next one is still going to be u and v plus m, and the third one is going to be v plus a minus 1, which is 3 minus 1 is 2, so this is going to be 2m. So u, v plus m, and the third one is going to be u plus 2m. What is this going to be? This is going to be u plus r. So the first one is going to be u plus r and v, and the next is going to be u plus r, v plus m, and then u plus r 2m. And this way we will get the total of a times b is equal to n unit would be the total units. This is how we will calculate the sampling distribution in 2 units. Now let's do a quick example of this. Suppose we have a n of 9 and a and b are both 3 and m is 3 and r is 4. So we'll create this kind of box here. We'll do these 3 and 3, and then here M is 3, and so we got 3 here and then 4 here, right? So these are M and these are R, and this is A and this is B. So now what we have to do is, first we will select a random number. For example, we selected a random number 2 and 2. So if we select a random number, say 2 and 2, this is going to be somebody here. Now we're gonna move, R is 4, and so we're gonna move 4 steps to the right, and M is 3. So this is how we're gonna do. We're gonna do 2. So the first is going to be 2 and 2. The second is going to be 2 and 5, and the third is going to be 2 and 8. And then we're gonna move 4 steps here. So this is going to be 6 and 2, 6 and 5, and then 6 and 8. And then we're gonna move 4 steps more, which is going to be 10 and 2, then 10 and 5, and then 10 and 8. Now we have now selected these units in all the categories of all the 9 units based on a systematic sampling.